Today we're going to talk about antimatter. So as we know that antimatter meets matter and goes kaboom. For example, in here. So we have a positron, the antimatter phase of electron, and an normal electron. They go together and boom, releases energy, a lot of energy. So the positron is the antimatter of an electron. The theory of antimatter or antimatter was first created by Paul Dirac. He formulated the theory, and he says that for every matter particle there will be an antimatter particle. See, but Paul Dirac also is also one of the important founders of quantum mechanics and quantum field theory. So for every particle there is antimatter phase. So for example, we have electron and positron. If you notice, there's the plus and negative sign here. So we have electron, which we all know carries negative charge, and the positron, which carries positive charge. So notice if we have a negative charge, turns to positive charge, and vice versa. But let's discuss what happened if there's no charge, like quarks and neutrons. Well, antineutrons and antiquarks, it's just antiquarks and antineutrons. Antiquarks made antiprotons, which carries negative charge. But a quark itself doesn't have a charge. So basically it's just an antiparticle with no charge. So is quark. It's just particle with no charge. But they still ignite each other when they meet together. Also works the same with antineutrons. Next, we're going to talk about, like most people use antimatter as weapons and energy resources. Yes, they could be a viable weapon and a viable energy resource. For example, if I drop antimatter bomb somewhere in the city and boom, the city dies. Or we can use them. We can harvest this intense energy and then use it for ourselves, which we are still discussing. And also, most people thought we can carry antiparticles somewhere just by not letting them touch anywhere of the container. But no, people have thought years to carry antiparticles. The key is you have to keep them spinning. That's why the CERN has ATLAS to preserve the antiparticles for further experiments. You can't just put them in a case and carry them anywhere. That's not like in sci-fi movies. Also, we like to talk about is the symmetry of antimatter. So we all know there's a lot of matter and a tiny bit of antimatter. Why does that happen? So in the Big Bang, blows out, and so there's quarks and antiquarks, antiprotons and protons, and antineutrons and neutrons. So that we'll discuss when we're talking about cosmology and the Big Bang. So in that time, there's basically Hawking says that the basic equal of antimatter and matter, but something strange happened. They went to like a little fight, like a war. The kingdom of antimatter, the kingdom of matter. They go together and matter won. So there's basically a teeny tiny bit of natural antimatter left. And that's why there is more matter than antimatter. Also, as thing we discussed is the multiverse. So multiverse, we can know that they don't have to all be like matter or stuff. They can be strange matter and all sorts of stuff. So that's basically we'll talk about in further episodes. We're going to talk about much more complicated stuff. Thank you for watching this video, and see you next time.